for summer. And she'll actually be with our teachers tomorrow doing more professional development. All of the teachers will be broken up into some different grade level groupings and have 2 hours with her for continued professional development as they're learning all of the implementation strategies and the ways to bring this into the classroom. So we're excited about that, and I'm going to have her come on up here, and she'll give you an outline tonight of what you'll be learning about with the curriculum. So our goal for tonight really is that you would come away understanding more about math and focus. We can share with you more a little bit about why Grace selected this program, where we're so excited about what it's going to do for our students. And then you'll get an opportunity tonight to do some real hands-on learning with the program and see what it's all about. So if you could welcome Kathy Butler.
Thank you very much. I'm thrilled to be here this morning. I am from Arkansas. I did teach many years. I taught 42 years in classroom. And I taught math and focus for many years. I taught third grade math and focus. I taught fifth grade math and focus. And then when I announced my name,
If I answer the question during the session, they'll move it to the side where we won't address it at the end, okay? So if you have a question, write it down and raise your hand, please. Just raise your hand. Someone will come and pick them up. Yes, thank you. Okay, thank you. So hopefully I'll address most of those during the next hour. Okay, so why do we change? The world's different than when you were children and than when I was a child. Business leaders, industry leaders, they're saying that, you know what, children weren't coming through prepared for all of these new jobs that are coming up. What are we going to do to make sure that our children are prepared? There is a lot of research out there on how children learn. And for many decades in the United States, we have ignored the research. There is still a lot of research even going on. I know like at Sept University, and it's exciting to see what's coming out of that now. So we will continue to change the way we teach using best practices and research-based practices. Why Singapore? Why a program from Singapore? The results, and I'm going to share some of those results with you. Their children are proficient in mathematics. Not only computation, but we're talking about applying math. They're critical thinkers. They are problem solvers. And that's what we need. We need to encourage that piece. We need to help our children to become problem solvers. So, I'm going to go. I gave you a test, and I was hoping that you would talk, you would share, exchange ideas. We want our children to be communicators and to be able to explain their thinking, justify their reasonings, debate with others. This is part of math class today. Can children work together? Think about the workforce. Do any of you have to work with other people and explain your thinking? In the past, in math class, we said, oh yes, you're correct, 284, that is the correct answer. And then we just move right on. Math is much more than just giving the correct answer. It's understanding the problem solving going into it. Can I explain my project to someone else? So, this was like over 20 years ago in Singapore. They had been, Malaysia kicked them out of their country. They were a very poor country. The children were not doing well in education. So they went out and said, we've got to change this. They started using textbooks that were already out there that they brought. Didn't make any difference with the kids. So they went and read and brought people in to help them understand the best practices. What is the research out there? What is it telling us about how children learn? So they developed a framework, and then eventually they developed a textbook, and then they continually revise When there's more research, then it's time to revise those books. So, over 20 years ago, and this was only 26 countries at that point took this international exam. There were 16. They were not pleased with that. Over the last 20 years now, they have been a top performing nation on the international exams for the last 20 years. I believe there was 1 year, and I can't think what year it was or which international test it was, that they were like number 2. Most of the time, they're number 1 in the world. So what are they doing? I'm having problems with my clicker. Okay, so let's look at this one. This is from 2015. This is the TIMS exam is given every 4 years. So this is the last set of data that we have. Notice Singapore has a score of 618, United States 539. 40 points is 1 grade level. Okay, so let's look at the type of questions that are asked on these exams. So look at Singapore and go over to the column that says low. Okay, 99% of their children did well on computation. Add, subtract, multiply, divide. We did well also. 96%. Or 95, I can't tell what it is. Okay, 95%. So there were different levels of questions. The low-level questions are just basic computation. The intermediate type questions were like one-step problems. You can see the score on that one. The higher level questions were multi-step problems. The advanced questions was where the children had to analyze and apply what they have learned. They haven't seen any problems like this before. These are unique type problems, but they've learned all the skills that are needed to solve the problem. Notice, Singapore, 50% of their children could apply their math. United States, 14%. Well, which way am I going to? I don't know where to point it. I can't get it to change. Okay, 8th grade. I'll let you look at that for a moment. Okay, again, I'll let you look at those. So, the Singaporean students, 54%, did well on the advanced type problems. Only 10% in the United States. There's one more test that I want to show you. One more. Well, I guess we're not going to go that now. This was one of the test questions. 4th grade. So on the left, 54% of U.S. 4th grade students answered it correctly, 81% in Singapore. Let's look at another one. So what makes this one tough? Anyone? Well, normally we usually say, okay, the length of a rectangle is 6 centimeters. The width of the rectangle is blank centimeters. What is the perimeter? Notice how it's written differently. So, how did we do? 22% of those in the United States. I have to switch clickers, I'm sorry. It's not going back. hold on. There it is. Okay. But 86. Well, that's what I had asked them earlier. Which way do I need to point it? And they said, where? Point it to my computer? Thank you. Thank you. Okay. And 86% in Singapore, fourth graders answered it. And that problem didn't seem that tough to me. So what are we doing in our classes to get our children to another level? It can't all happen in 1 year, okay? It's going to take a couple of years for us to encourage the kids, for you to be supporting your kids, to encourage this thinking. In 2007, My Cows Are Here, which was the Singaporean textbook at that point, 80% of the classes were using it, came to America, and it was called Math in Focus, and they Americanized it. So here's the framework. In Singapore, they said, okay, yes, we get adding and subtracting. We know kids have to do that. But the heart of math is problem solving. We know that concepts have to be taught, number sense, statistics, data. We know skills need to be taught. How do you read a ruler? We know processes need to be taught, different strategies like thinking, guess and check, logical reasoning, working backwards. And we have always done all of those things in the United States. I've done those, I did those for 42 years in the classroom. That's not new. This is what's new. Metacognition. Do the children just start on a problem immediately when they get it? They look at the numbers and just go to town and start writing on their paper? Or are they slowing down and really thinking about what does that problem mean? Does my answer make sense? Is it reasonable? Can I explain my thinking to someone else? Attitudes. Encouraging effort. And that is something I challenge all of you to do. If your child comes home with a difficult problem, praise the effort. Praise their struggle and their perseverance. It's not always about if the answer is right or wrong. So here is the framework that they came up with in Singapore that's still used today. So here's the differences. Many, many, many years, I lectured in math class. I stood up at the front of the room at the chalkboard, and I modeled how to add, how to subtract, how to multiply, how to divide. Step 1, step 2, step 3, step 4. That's how we got, like the 99% of our kids or 95% of our kids can do well on computation. But my children would not have done really well on that 4th grade TIMS test because I wasn't challenging them. I was just doing basic math. So much more than just computation. Now I'm looking at the flags of Japan and Singapore. The way they teach is totally different. They're going to pose a problem just like I did to you. They're going to solve it different ways. They're going to share their thinking with others. My job is to be questioning, is to facilitate the conversation. Not to be up here explaining in detail. Step 1, divide. Step 2, multiply. Step 3, subtract. Are we going to do that? Yes, we are. Are we going to learn the standard algorithms? Yes, we are. But the difference is with understanding by using the manipulatives and drawing pictures. So, the math's the same. The math in the textbooks is the same. It's how it is taught that is different. It's not the telling method that you and I had. It's problem-solving based. So, I'm looking at a table of contents, and I noticed that one lesson, is 2 days. Or it might be 3 days. Or I know in 5th grade there was a lesson that was 4 days. So we're going to stay on that lesson for mastery. We're going to go deeper with those lessons. Deeper meaning, do we have the conceptual understanding that we need to understand, say, that standard algorithm? Okay, so we know concepts are important. They tell us why we are adding the way we're adding. We have to put those together. Your concepts and your skill building to develop the deep understanding that you want your children to have. And that takes time. Another piece that from this in Singapore, and you know what? Many textbooks now are copying a lot of the pedagogy from Singapore, but they're piecemealing it together, where this is an authentic Singapore program. Concrete pictorial abstract. A lot of you went to college. You learned about Piaget. And what did he want kids doing? Anyone? Playing and exploring, right? That's what we want in math class too. We want manipulatives to use to be doing that. We want kids exploring and thinking. Anytime there is a brand new concept introduced, manipulatives are used. For instance, if I was teaching 4th or 5th grade fractions, there's nothing better than just folding paper. That would be a manipulative. Pictorial, can you draw it? And then we go to the abstract. This is not linear, by the way. It may be that we were doing concrete and abstract together. The missing piece in America has been that pictorial piece. We used manipulatives in my classroom all those years. We did the abstract all those years. Some children still couldn't get math. The bridge is the pictorial piece. Can you draw it? Can you visualize it in your mind? Do you understand the problem? And draw a picture to match it, to help you figure out what operations you use, how to solve it. Okay. So there is the emphasis on problem solving. Now I'd like for you to look at this one for a moment. And I want you to think about, where would you start? Why 142? Why? Oh, because you can subtract 79 from it. Could I have started at 31? A lot of guessing and checking, right? Okay. So, yes, you're right. We would need to start at 142 and take away 79. So the kids are going to be learning about part, whole. 2 parts make a whole. If I have a whole and one part is missing, and I have the other part, I'm going to subtract. So, but there's more reasoning than that. Where do we go from here? What's the pathway? So children have to make sense of the problem and find the entry point. Now, I want you to think a moment. How many problems will be solved working this problem? How many computation problems will there be? Quite a few, right? So your child might have quite a few puzzle types rather than a worksheet with 20 math facts on it. They may be working with something like this, with a variation of that. This is much more engaging and much more fun. Now, this was collected at a faculty meeting about a week ago, and I would like for you to read it. And I want you to think about, at your table, discuss what is the overall theme from all of the teachers' comments. What do you see over and over and over again? What is happening in those classrooms the last month? What are the kids doing? I'm sorry, go ahead. Right, use of tools. What else do you see? Thinking. Do you see that over and over and over? I'm so excited to see these comments from the teachers. So, what is it going to look like at home and in school? Well, in school, we're going to be going deeper with a concept. Instead of just teaching it and moving it on, we're going to work on mastery. There's going to be concrete pictorial abstract used all the time. There's going to be differentiation in every classroom happening during the core lesson and outside of that lesson. And these are the instructional strategies that are critical to math from Singapore. The concrete pictorial abstract piece, visualization. Can you picture it in your mind? Not only that, it's also seeing the relationship of those numbers. Is one larger than the other? Math is thinking, the questioning going on. And then the gradual release model is where we start off the lesson with whole group, and then we release them to work in small groups before we allow them to go and work independently. So here are just some examples that you can see. If you're looking on the top row, I noticed that they're both solving a multiplication problem different ways. I see repeated adding. I see the using the base 10 blocks. Look at the bottom right. Finding perimeter, building it, drawing a picture. Now, this is the 4th grade problem, and I want you to think a moment. What do you think would be tough about this problem? Yes, it's a multi-step problem. What would be something else that would be confusing for children? Meters, decimals, meters. So I taught this lesson last spring to a 4th grade class, and I have some pictures. What do you notice? meter sticks. They can make sense of this problem if I pull out those meter sticks. They can find 1 65 hundredths of a meter using those meter sticks. That's concrete. So then look what's happened. Some of them drew a picture to model what was on the floor. That is pictorial. That is called bar modeling or model drawing. However you want to say it, they're both correct. And then we went to the abstract. So very clearly with that problem, you can see they needed to go back to concrete just to understand the problem, and then they could make sense out of it once they built it. So here is the lesson structure. The direct involvement means the teacher is directly involved with the whole class, asking questions, listening, facilitating. The guided learning is the children are now learning with each other. And then the independent practice. Now, the independent practice may not happen until the second or third day after a lesson is completed. Remember, a lesson sometimes takes more than one day. So we're gradually releasing responsibility to the children for their own learning. And the teacher is assessing all the time, nonstop. We have resources available besides differentiation happening in the core lesson with the teacher. Your teachers also have resources available. Now, this year, they're involved with filling in some gaps that your children might have from a previous year. So this program offers that piece. We do a recall prior knowledge of some skills that they should have had last year. We review. Then we give a pre-test to see, are those skills in place? If they're not, we have a transition guide, and the teachers know how to start filling in those gaps. Now, the pre-test is different than what you're probably thinking. It has nothing to do with the upcoming chapter. It is a test to see if they're ready to even begin the chapter. And you won't see that coming home. It's just information for the teacher. It's just an assessment so that the teacher knows what to do with each child in the classroom at that point. Okay, so at home, you may see worksheets coming home with pictures on them that might be different. You will see some standard algorithms. You might have some worksheets that have higher level questioning. If we don't give our children the opportunity to think, then they're not going to get it. We have to help those children understand the struggle, and the brain grows when we get things wrong. So on this worksheet, I'm seeing the base 10 blocks come on a worksheet. That's a visual. We might see something like this, where in this case you have the algorithm on the right, but notice the mathematical language that goes with it. 3 ones plus 9 ones equal 12 ones. And if the children are modeling the standard algorithm on the place value maps. A sheet, if you have, how many of you have seen a workbook at home? Okay, not quite half, okay. All right, so if you'll notice, the workbooks may have what, 2 on a page? Not a lot on the page, but there's more critical thinking going on in this program. So, homework is to be independent practice. Now, that doesn't mean that you can look over it. There are things you can do to help. But please, 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 don't let your child or yourself get upset. You haven't seen some of this type of math. The math is the same. It's the understanding the piece. Jot a note down, and I have told every teacher this. We tried. Initially, send it back to school. It's okay if it's not finished. The teacher will go from there and work through that with the children that need help. Please don't let frustration take over the dinner table after dinner. Sometimes you might not see any homework. They finished it in class. So, your children have all been in chapter 1, which is about number sense, understanding numbers. And one thing I want you to realize that when we're talking about place value, it's more than just saying, oh, the 3 is in the tens column. It's understanding what that is. So here I have a picture. So I have a green train, a green 10 train, and I have, I think, 5 ones over there also, a short train with 5. So which place value, Matt, and base 10 blocks match it? Again, using the standard algorithm, we're going to be talking about add the 1s, add the 10s, add the hundreds. Also, okay, these did look different on my computer. The place value is above it. Okay, I don't know what happened when it came up here. But also, notice, do they understand the quantity? Do they understand expanded form? What a digit means. There's so much more to it. Okay, so on your tables, you have place value maps. So get 1 for about every 2 people. And you have base 10 materials or chips, or blue chips, whatever you would like to use. And you may work with a partner. And I would like for you to build for me 326 on your place value mat. 326. Oh, by the way, please don't write on these. These will go to the classrooms. So and I didn't tell anybody that. I'm sorry. If you did, it's okay. No big deal. But build 326. You can use whatever you like. Okay, so notice at your table, notice the different ways it has been modeled. Okay, so I want to look at this table over here and share what they did first. So I noticed that they have how many hundreds? 3 hundreds. And how many tens? 2 tens. And how many ones? 6. The base 10 blocks, everyone look at a 100 block. If we had to, we could count 100 squares. Look at the 10 block. You can actually see the 10 different units. This is much more concrete than what a lot of you did using the coins or candy or whatever you used to build that number. When we move into 4th grade, we do go more abstract with like using the chips. Okay, so I want one person at the table to keep the placemat showing 3 hundreds, 2 tens, and 6 ones. Now, on another place value mat, build it a different way. Can you build 326 a different way? And I'm not talking about just using different materials.
Can 금방 chart not this fine. We have all this fine. Yeah, we have all this fine.
Okay, I'm going to give you a clue. Think about $326. I could have 3 $100 bills, 2 $10 bills, and 6 $1 bills. How else could I make $326?
뭐가 진짜 많이 and we escalate sometimes we find out. Yeah, I guess you gotta just slightly, or we need to see the more the top. Slightly more. Yeah, that everyone will be able to. Oh, you just improved.
So, here's another way over here. Would you share what you have, please?
I have 16 ones, a 10, and 3 numbers.
Can you come up with another way? Come on, tables, let's see. So over here, I'm noticing the digits, and I see, does everybody see the 3 is in the hundreds place? And I see the digit 2 in the tens place. And guess what's in the ones place? 6. Love it. Okay, so did you find another way? Okay, let's see. I know there. Yes, would you share, please?
32, 10,
And then 6 ones. You are decomposing 326 and really thinking about what does it mean. Now, I want to put a problem up here. 326 minus 118. Which one of those would be the easiest to use if we were subtracting? What do you think? So, if we were building on our fireplace value mat. Would it be easier to subtract 118 if we built 3 hundreds, 2 tens, 6 ones, or 2 hundreds, 12 tens, 6 ones, or 3 hundreds, 1 10, 16 ones? Which one would help with that subtraction problem? Okay? But what about if it was division? Then what would you have? Right, right. See how decomposing numbers helps us even work the problems mentally. So, moving on, I've already told you that a pictorial piece was the missing piece in our instruction for many, many, many years. So, we're going to be using a lot of different graphic organizers to help us organize our thinking. And a 10 frame is one of those. So what is 2 more than 6? So I build 6 on that 10 frame, and then I count on 6, 7, 8. Or maybe for subtraction. How many of you have seen 10 frames before? A few of you? Okay. So they're very prevalent in kindergarten and first grade. And kindergarten's not there yet. They'll start with 5 frames. But this is a piece that is so helpful for kids to start visualizing quantities in their mind. Okay, so let's all count to 4 with me. Ready? 1, 2, 3, 4. Okay? So I want everybody to take a train, take 4 cubes, connected. And if they're going horizontal, it's a train, but if they're going vertical, they're a tower. And I want you to hold them over your head. Okay. Now, take it apart. And then stop. What is 4? What is 4? You have what? 1, a 1, a 1, and a 1. Oh, that's 4. But what do you have?
2 and 2.
Who has something different? What else is 4?
What else?
3 and 1. 3 and 1. Or 0 and 4. So one reason in kindergarten it seems like we start off very, very slowly is I know a lot of your children come to school and they can count to 100. That's only one aspect of a number. It's just counting. It's just memorization. It's just rote learning. What we've got to make sure the kids have is number sense. What is 4? It's 2 and 2. It's 4 and 0. It's 1 and 3. In first grade, we use something called a number bond. And again, it's just another graphic organizer where we have the whole, which is 4. We break it apart, and we have a part-part whole model. This is called a number bond. We use it throughout. Now, notice what these kids did. Think about what is 20. Yep, all of your kids can count to 20, but do they know what it is? Think of coins. What is 20? 2 dimes. What else is 20? 4 nickels. What else is 20? Okay, so do kids understand quantities? Do they understand what that means? Here's one with 3 parts. But then notice what this little first grader did. Wow. Wow. That's extending their understanding. So in the red, I have circled 20, and then they went from there. Now the one on the top left, really that child should have started another number bond, combined 2. Think of all of that practice going on with these kinds of activities. Okay, so learning facts, we use related facts to learn new facts. Kids, your children in kindergarten and first grade will be learning how to visualize what 9 looks like. they'll know 9 filled in, 1 not filled in. How many more do I need to make 10? 1 more. So the problem's 9 plus 5, but I am making it into a simpler problem. I don't know. I can't think what 9 times 5 is. Okay, so I know 9 and 1 make 10. So 10 plus 4 is 14. So 9 plus 5 is 14. Making 10. So how many of you have first graders? This is a hard skill, learning these addition facts. And they're not to this point yet. It'll be another few months before they are. But let me just give you one little idea. We are going to play Go Fish. Okay, so the object of the game is to make 10. Do you have a 4? Okay. What did I have? A 6. Okay. You have a 7. Go fish. Do you have an 8? Okay. But I just want you to play games with your kids, just things that you know how to play, like go fish. We can even do it with doubles. Do you have a 4? And if I have a 4, I would say 4 and 4 make 8, and I win the book. So just think of things you can do at home to make it fun. Okay? All right, so we were working at school on making 10. Let's play Go Fish. Now, I want to show you all of your children. Now, chapter 1 was fairly easy, the test. They're going to begin getting a little bit more difficult. This is on the first grade test. And I want you to notice, we have been working on number bonds in class. What's tricky about this problem? They've not seen anything like it yet, but they've learned the skills. They know part, whole. If I have a part and a part, I'm going to add them up to find the whole. They know if I have a whole and one part, then I'm going to subtract to find the other part. But what's tricky here? Working backwards, finding the entry point. On the Tims, this would be a 4. This would be advanced. No, we don't expect everyone to get it, but we expect them to try and get as much as they can. So the tests are going to have some questions that you're going to be thinking, that teacher didn't teach that. Well, they've had the skills. Can they go to the next level and develop that critical thinking and apply what they've learned, analyzing, to get the answer? Number bonds, 3rd grade. You know how tough it is to add time, subtract time? This is a simple way to use the number bond decomposing time so that we can do that. All right? So I want to go to another organizer. Bar modeling was developed in Singapore, and I really can't tell you how many years ago, because their children were not getting problem solving. You remember how we used to always hate word problems? That's what it is, word problems. So they came up with pictures. Can we draw a picture to represent the problem? And this begins in 2nd grade. and it goes all the way through 7th grade. So there are different kinds. Look at the part whole, very similar to the number bond. Equal parts would be multiplication and division. Comparison problems, one is larger than the other or smaller than the other. And we could use those for adding and subtracting, multiplying and dividing. So why are they important? It's that picture piece. Can I draw the situation? Can I draw what the problem is saying in a picture form? If I can, then by just looking at that bar model, I know whether to add, subtract, multiply, divide, what I need to do. They can see the relationship between the numbers. One is greater than the other because of the length of the bars that we're going to use. So I said bar modeling starts in 2nd grade, but it really starts in kindergarten at the concrete level, not drawing the pictures. So I have 5 cookies. Mario has 3, Natalie has 2. So we start with the real objects, and then we go and we build it. And then we start putting them together, 3 and 2. Think of your train, pushed together would make 5. And then in 2nd grade, we draw the picture like it is in the bottom model. We use rectangles because it's easy to draw. That's the only reason. So this is 2nd grade. So if I had say I had 10 pennies and I had 12 pennies. How many do I have to put in my piggy bank? Part, whole, and I put them together. So think about what this would look like if I placed it on a piece of paper and I drew around it. Do you see the rectangle? Okay. That's a bar model. This is a part whole model. Okay, so think of this one now. The sum, if you recall, is the answer to an addition problem. So the sum of 2 numbers is 36. The smaller number is 1/3 of the larger number. Find the 2 numbers. Take a piece of paper and solve it any way you want to. what? 12 and 24. I bet a bunch of you do. Okay, all right, so I see hands up all the way around. But let's see if we can draw a picture of it. And I love how I see some of you modeling with the cubes. Okay, so we know that one number, oh, I'm sorry. Okay, so, all right, so let's look at this. The sum of two numbers is 36. The smaller number is 1/3 of the larger number, so can I simply just draw a picture to represent it? Does that make sense? Okay. Find the two numbers. So what do you notice now? There are 4 pieces, so what are we going to do? We're going to divide it by 4, aren't we? So then the smaller piece would end up being what? 9. 1 unit is 9, so 3 units would be 27. But look at the picture. Doesn't that explain the problem? Okay, let's try another one. See if you can draw this one. Carl and Ben had $4,686 altogether. Carl's share was twice as much as Ben's. So what was Ben's share and what was Carl's share? Draw a picture. It's 9 and 27. 9 and 27, yeah. While we're working this, there's water at the back. Please go get some water back there also. They're passing cookies out. And there's chocolate on the table. Oh yes, it's not just a snippet, it's to eat. Okay, is it? Okay, so I just want to make y'all feel better. You've been here 1 hour. I spent 2 weeks on bar modeling one summer before I started teaching 3rd grade. Then my brain went click. It takes time, it takes practice and practice and practice. I don't think algebraically anymore. I think of the relationship of those numbers, and I go straight to bar modeling. Okay, so let's see what we've got here. How many of you drew the units? Carl's share was twice as much, so he gets 2 units, and Ben gets 1 unit. And you can see how much money they've got, right? Now, that's 3rd grade problem. Look what happens, though, when they get to 5th grade. Do you see the relationship? 2x and x. 3x is the same as those 3 units that we just drew. Algebra makes sense after we go through the bar modeling. Okay? Ooh, are you up for a tough one? Okay, this This will be the last one. I think it is. So, this one I'm going to walk you through and help you get started. Let's read one sentence at a time and draw it. Ricardo spends 8/9 of an hour reading the newspaper. Can you draw that bar model? 8/9. Okay, so I see a lot of people drawing one bar. It has 9 pieces, right? Okay. Now, how much of the 9 pieces, okay? Well, he's reading 8/9 of an hour. Now, think about that 8/9. He spends 1/4 of that time reading the world news. Can you show me that on your picture? So what is that? 1/4 of what? 8/9. And then he splits the remaining time equally between sports and comics. How much time does he spend reading the comics? See how we broke it down one sentence at a time? Okay, so let's look up here. You have 8/9 of an hour he's reading. Then we take those pieces, those 8 pieces, and we divide 1/4 of it off for reading the world news. Then we split the remaining time into sports and comics. How much time does he spend reading the comics? 3/9 or 1/3 of an hour. Wow. Does it make sense? We took one sentence at a time and drew the model. Okay. So, look at the research for middle school. I'm going to just let you read it by yourself. When it says CPA, it's talking about concrete, pictorial, abstract. See how all of this leads right into 6th and 7th grade math. This problem of linear systems, the very first problem we worked that I said was the 4th grade enrichment problem, elimination method, here it is. Now, we are going to encourage critical thinking and problem solving. We want your children to become problem solvers. Not calculators, problem solvers. Do we want them to know their facts? Yes, we do. Do we want them to know standard algorithms? Yes, we do. But the difference is with understanding. Do they understand why they're doing what they're doing? This is first grade. Look at that. We're not doing A, B, and C with them, but it's exactly the same thing, isn't it? This is an enrichment problem at the end of first grade that some children would be able to figure out. So differentiating those kids that are ready, we don't want to skip them and move them to second grade. We want to stay where we are and go deep right then where we are. So we're right here, we're advancing the thinking with adding and subtracting without moving them to another grade or just making the numbers larger. So, what can you do? The first thing I want you to realize is the intent of this program. So that textbook is just a book. It has practice in it. But it is not how we teach. We're using the Singaporean pedagogy in our classes, how we teach the material. Your child's having trouble at home. Start with questions. What do you know? Look at the first sentence and tell me, what do you know? Read the second sentence to me. Tell me, what do you know? Well, what are we trying to find out? Can you draw a picture for the first sentence? Can you draw a picture for the second sentence? My third graders would come up all the time to me, I don't know what to do, I don't know what to do. And I would say, they'd bring their workbook up, and I'd say, did you look at the example? And you know what they would say? No, I didn't. Even though it's right there on the page for them. Ask them, what can you tell me, what did you do in math class today? Can they give you a description? If you get stuck, write a little note. Sign it, send it back. Play games. And the things I have listed up here are things that you probably have at your house, or you can go to Target or Walmart and buy them. Cards, dice, dominoes, graph paper. Play games you know. Go fish, battle, war, whatever you want to call it. Tic-tac-toe. All of those are good ways to practice facts and develop number sense. And I do have some examples. That was goldfish, where I told you make it 10, make doubles. How about matching? Kids need practice just with facts, right? Okay, so I put up the number 9 in a card. Can you match the dominoes? Like 3 and 6 make 9. Oh, I'm going to put it over here with the 9. What else makes 9? Using first grade, they need to know what's larger. Is 7 larger or is 9 larger? You can play cards just with that. Whoever has the larger quantity gets that book of cards. Or less. Switch it up. Also, you can practice facts. Take 2 cards. Multiply or add them together. Who wins? Oh, I do. I've got the greater product. Graph paper you can buy easily. So let's look at tic-tac-toe. So one person is writing in the red and one person's writing in the green. So 4 in a row, 4 horizontal, 4 diagonal, then you get a point. But what else is neat about this is, hey, can you ask them, can you predict a pattern? Look where I have the question mark. Can they find a pattern with it? Interesting. I don't know what happened on that one either. Okay, a hundreds chart. Same thing, tic-tac-toe. Can you find 4? A hundreds chart goes across 1 to 10, and then 11 starts back on the left-hand side. They're counting by threes, they're counting by tens. It just depends which direction they're going. So, why math in focus? I love the comments that your teachers made about the thinking piece. They're thinking deeper about math. It teaches to mastery, emphasizes problem solving, critical thinking. It has built-in strategies for all children, and it provides professional development for your teachers. So, when we put the pedagogy with the textbook, and the textbook is just content, it's not exactly, it's missing the rich conversation going on in the classrooms and the activities and the manipulatives. It's just providing practice. It's not how to teach math. So when you put those together, you do get math in focus. Now, did y'all organize the questions? Let's see what we've got here. Did I answer any of them?
Yeah.
Oh, good. Okay. And I did ask the ladies to answer questions with me, too. By the way, I know it's late, and I know this is 2 hours tonight, supposed to be up to 2 hours, but if you need to leave right now, and you don't want to stay for question and answers, feel free to leave, that's fine, okay? If y'all would just kind of put all the chips back in the baggies for me, I'd appreciate that. And all the things back. Okay, so learning math facts is going to happen all year long. Okay, about the middle of the year in first grade, chapter 8, they're really going to hit math facts pretty hard at that point.
I just wanted to jump into about the math facts. Yes, our students are still learning their traditional math facts with the expectation like we've always had when they're learning their addition, subtraction, and multiplication facts. That is still a piece that's included, and we'll be doing that still separately from math and focus curriculum. I'm going to just add on a little bit to that, which may answer some of the other questions that we have as well. One of the reasons that we looked very closely at math and focus, and really this has been for our school internally a 3-year process of examining our math program. Our students do an outstanding job with computation. They can rattle off their math facts, they can apply them into the procedures. But the problem solving, like you've seen tonight, our kids struggle with. We've looked at our standardized test scores over the past several years, and really 3rd grade and on, we have seen our scores good, but not great, not where we want them to be. From top down, our teachers who are teaching our calculus, our geometry, our algebra classes, they're finding that our students are struggling in the problem solving and getting into those deeper reasoning skills, the critical thinking, that this foundationally will give them. We wanted to equip our teachers, especially with those good professional development resources, showing them how to teach math, how to be able to build this math conversation in the classroom with the students, how to get them to find that there are multiple ways sometimes to solve these problems. We wanted to equip them so our students can do well with that. The problem that we saw up there with the shapes and equating those to numbers and then coming up with a solution, I was proctoring our students in 6th grade with ERB testing this week. They were struggling with a question almost identical to that. And I can see it's the problem-solving piece. We went to a number of schools. We took a large number of our teachers across different grade levels and different teams, and we visited schools throughout North Carolina, Charlotte, we were in Greensboro, we talked with other schools, we watched classrooms across different grade levels. One school was in their 1st year with Math and Focus. There were others that they were into their 4th, 5th year of Math and Focus. The difference in their math ability, it was phenomenal. they really were doing an impressive job, even in the lower grades, with their thinking. And we walked away saying, we want this for our kids. We want our kids to be able to get to this level with their math. We want our teachers to be well equipped. So I think that jumps into a little bit of a few of the questions that you had coming next.
Whenever the kids don't get it at school and they come home and the parents don't get it and we don't know how to help them because we've never learned how to do it, and then the kid's frustrated, the mom's frustrated.
That's a good question. Part of it is things like this, having parent nights, time where we can get together with you all and train you. One piece that's included with all of the grade levels at the beginning of each chapter is a letter that's called Parent Connection. And then there are videos that go along with that. And one thing I'm working with Kathy Cole on is getting every grade level's parent connections and the videos all on our website. So you can go on and you can see that grade level progression. So if you have a second grader, you can see what second grade is doing, but then you can see up into further grades what they'll be doing and how that builds.
Can I specifically ask, I have a fourth grader, can we see like the second grade stuff so that we can understand what the foundation is in order to be able to build on it and teach them? For example, like my daughter just doesn't understand the visual of the 10 because she's never learned it. So in order to apply that, I need to understand what they've done in first, second, and third grade.
Right.
In order to teach and help her with fourth grade. So I'm just wondering if we'll have access to the lower grade.
That's what we're working to get on our website right now.
So we'll be able to see all of it.
Absolutely. And the videos go through the step-by-step of how to do different problems. Yeah.
Okay, what about for a sixth grader? This is based on years. So
Right.
is the sixth grader going to learn this and then it's going to carry up to 7, 8, 9, 10? How's that going to work?
The way our curriculum works right now, the way we have our courses, sixth grade is our first year for our differentiation in our math program. So we have Math 6 and then we have pre-algebra. And truthfully, we really debated about whether or not we wanted to bring this program into sixth grade, knowing that students have not had this up until now. We had a lot of discussion with our middle school and high school department. Courtney Blunt, who's the Math 6 teacher, she felt like she couldn't wait. We really needed to bring this in to build those problem-solving pieces. And over the past several weeks, she's been working a lot with students on just with the number sense and working with them on the number line. A lot of them were having difficulty with that. She feels like we've been able to go deep with that. They'll still continue on to pre-algebra in 7th grade, but the foundation, those pieces, and all of those standards will still cover them, but they're going to be able to learn to apply this, which will work beautifully in the leading into pre-algebra.
During the transitional phase, would you offer like camps or boot camps or like tutoring sessions for the children to kind of get up to speed in the first year or so?
Several of the people, within the curriculum itself, there are reteach pieces, there are parts for going into math teaching, for students that are already grasping it and they're ready to go on, where there were some of the deeper pieces that you saw today. All of that differentiation is what's built in. And that's what our teachers are learning how to do right now in their training, to be able to go through some problems, assess which children get it, and they're ready to go on and do other things, and those that they need to reteach and do some more work in small groups with. Yes, we're mentioning to help classes after school. There are definitely ways that we'll be able to work with kids. What are some of the other questions that you have?
Is everybody good with what resources parents have? How do you help your children at home? You feel like what's the website? Is it ready to go?
We'll be on Grace's website.
Okay.
It'll be under the academic section.
And it's already there.
Kathy Cole's getting all that ready to go up. We're adding all of the grade levels in all the videos. Our introductory training with all of our faculty, 6 hours of training prior to summer, and that launched them. They were able to get started this summer, going through their resources. There's a lot available for them online. As I mentioned, tomorrow, it's one of the beauty of being able to have the parent training tonight, and then tomorrow Kathy will be here also, and we're doing 2 hours with each grade level throughout the day. We have a staggered schedule so they can be able to get that training in their day tomorrow, and then that's continuing and ongoing. The questions our teachers have now, they would not have had in May, because they've now been teaching the curriculum Many of them were able to do that, but they weren't trained in these specific problem-solving strategies that we know are so effective. So that's what we're doing in our classroom.
There are a couple of questions asking how this program compares to Common Core.
Okay, this program began before Common Core. A lot of the research came from NCTM, the National Council of Teachers of Mathematics. They went and they took the best research out there to develop this curriculum. Common Core looked around the world and selected the best pieces they thought would help children and wrote their standards. This book is Singaporean. Common Core copied a lot of those pieces because it's good math. But this is a Singaporean program. And again, NCTM was critical when the educators in Singapore were looking at what we should be doing in our math classes.
Just to piggyback on that, the NCTM standards are what all of your assessments are going to be aligned with. Our new assessment with ERB is aligned with that. PSATs, SATs, ACTs, they're all using these same math standards. So Grace is not a Common Core school. I want to make that very clear. We are not teaching Common Core standards. We are teaching best practices. We are teaching best learning for our children in the classroom. And we want them to be able to perform well on tests that are going to be coming up in the years to come. PSATs, SATs, ACTs. That's data that we looked at when we were examining math curriculum and what would be best. Mandy Gill, our high school principal, is here, and we looked very closely at our SAT data and where we were lacking in that for our students. And it all revolved around that problem-solving piece. Our children being able to dig deeper and have that more of that understanding. So again, we're not teaching Common Core, we're teaching best practices in math learning.
These are very specific. How does the simple addition and subtraction with rounding work? And then why are we teaching front-end estimation when rounding is more accurate? Those are more, I don't know.
Okay. I did make the suggestion in May, but it was 4 months ago, that we could skip the front end estimation. It's very confusing by the time it gets to 5th grade, and just to do the traditional rounding. So I will mention that again tomorrow to the teachers.
Okay. And then the simple addition and subtraction with rounding, how does that work? That's the question here. I don't know if you want to ask.
It's just the traditional, I mean, if it's tens, you're going to round to tens. If it's hundreds, you're going to round to hundreds, then add them up. So it's what they've always done.
I think that covers everything. But if any of you have any questions you feel like we didn't answer that you wrote or that you have come up with since, please ask. So you just said that you suggested to see.
No, well, the front end, because it's not a standard that your school is using.
Okay. So I guess this is my problem with this so far that I've seen is, and again, it's just me, but when it's coming to the multiplication for the fact that he knows, I really love brevity and I love that because he is very literal. So when you're asking, well, 8 times 2, he gave me 16, that's great. When we're having to go around the earth to come up with what 16 is, like, 8 times 2 is 16. So, and then that was what you said, I suggest you know. Will you guys go through this multiplying model, or will you guys,
Oh, I know, is that multiplication?
will you
okay.
guys do that, or do you guys want to embrace it? Or is it tailored to each individual class, or is it tailored to the school?
Okay, so what you're looking at right now is multiplication in 4th grade. It's a lesson, and it's moving from the traditional When I do it, I throw out the problem. And I just look around to see the different strategies, okay? Some are doing the traditional algorithm. Some, and I'm trying to move them to the area model, which is what you're seeing right there, which is using the distributed property. So it's going deeper than just using the multiplication algorithm. But it doesn't say that. But that's what's happening.
If that's the one, I'm not sure. I get 38 here. This says 39. They have to decompose it. Okay, so go back and okay. Let me do that later. We'll do that later.
Okay. Any questions for the whole group? Yes.
So, it's similar to that. Like, my daughter had a question yesterday, like, what's 10 plus 12? She knows it in 2 seconds, but we couldn't figure out 6-step process to answer the question. So my question is, like, if they know the answer, they don't do it the uniform way, they get the answer wrong, they didn't follow the method?
No. We want multiple representations. Now, and the teachers have to learn how to do all this. They're not going to learn it overnight. If they haven't been teaching this way, it's a process, okay? It takes time. We want teachers sharing out 2 or 3 strategies. And then the last strategy that we share out that the kids have come up with is going to lead back to the problems in the book. And I'm not sure what problem you're talking about, but yes, we are going to, if the answer is correct, it's correct. So what grade are you talking about? 3rd grade, okay. So specific questions, I think we just need to kind of answer one-on-one. Does anyone else have a general question? And everybody is welcome to stay if they want to.
So the answer comes when it's counted wrong, and they can't.
Well, we'll talk about it. We need to look and see what is the goal for that chapter. Is it to understand partial products? Is that part of it? I don't know. We need to look at the goals and the intent of the learning. Yes. Well, this year is really the toughest year.
Right, so this year,
No, they're good teachers. They're good teachers. We're just going to tweak. I can't answer that. Every teacher's different. But I mean, I'm saying I started making changes, and I mean, it's just so much more fun and engaging once the teacher makes that shift. Instead of standing up here and explaining everything, if the teacher is already asking more questions, having kids work together, that's a positive.
From schools that we visited, they said year 1 was the year where they spent a lot of time, professional development, time in faculty meetings, and working together, working in their grade level teams. We've actually restructured our schedule this year to give grade level teams more planning time together. And that's making a big difference for them too, to be able to work on these things in their grade levels individually. But schools that we visited said after year 1, they really felt, okay, we've got this, we're moving forward. Then the level of the professional development steps up. They're digging deeper, they're trying new strategies, they're doing different things in the classroom, they're going deeper in their teaching. So this will continue to grow, and they were able to share with us test scores for students. Students are improving, they're growing, they're learning, they're being able to apply things differently than they had in the past.
Yeah, I think I like the approach. I think it's great. I think it gives us a lot of money out of things.
That's the.
You can't calculate. But just you hear from a lot of questions from parents. You see there's one process on everybody.
Right, including the teachers.
Yeah.
So you have to just, give them some space too.
With the comments you made around, it's not necessarily wrong if they don't get it right. They get it right on the.
Well, no, I just said, don't let frustration build. Just jot a note and send it back to the teacher.
Right. I mean, that's
That's what I want you to do.
Yeah. So we got to commit to the teachers that that's okay and.
I have told them that, but I will emphasize it again
We
tomorrow.
reinforce that as well. When we looked at this program and we knew this was what we wanted to adopt, we had talked about, do we go one grade level at a time? Do we do a couple grade levels and stair step it in? Or do we adopt the whole program with everybody? This was not an inexpensive program to bring in either. This was quite an investment for our school. The manipulatives alone, were quite an investment. The professional development, it's a big investment. But we felt like it was so valuable, and we wanted everybody learning this all at once. And we're continuing with the best practices that we've always done with having students get mastery with their math. We're continuing with a lot of those methods that we know have been effective. We're bringing this in. This was the missing piece for us within our program. Yeah, please do.
I also don't want you guys to walk away tonight feeling like, okay, this first year is going to be rough. Our kids aren't going to get any math this year. They're not going to understand anything, because all the schools that we visited and we talked to, the teachers said, yes, it was a challenge to get through, but at the start of the next year, they could see such a difference already in the critical thinking skills of the students. The students made a ton of growth in that first year, even though there were challenges along the way. They could already see huge gains in the math skills within the children.
And also, I just want to assure you that the teachers, our teachers, are digging so deep and working so hard to be able to implement this and to learn the new ways to teach. And I've worked alongside of the teachers for such a long time, and they're good teachers. In fact, my children have had many of these teachers, and it takes lots and lots of work on their part. And your attitude towards your child and what your child is doing is paramount over everything else. Because if you're positive and you're on board being positive, your child's going to be positive. They're going to mimic what you feel and how you feel about it. So if you feel anxious and uptight about it, they're going to feel anxious and uptight about it. If you can just write on that piece of paper, we didn't get it tonight to your teacher. My child needs a little bit more help. Let your teacher worry about that. You don't need that stress at home. Home's got to be the same place. And you've got to be able to support your child, but also encourage your child and have those positive attitudes, because that is more important than anything right now. This other stuff will come. This is a blip in your child's life. 1 year in school is a blip in their life. They've got so much more ahead of them. Don't make this a stressful year. Whether you're kindergarten or 6th grade, I promise you, there are so many more things that are so much harder in your child's life than just this. Let this be easy. Let this be the positive thing.
And honestly, I think we've got to keep the goal in mind. The goal is for us to have problem solvers, critical thinkers. We want our students to be able to, we want your students to be able to function at a high level when they get to high school and then on into college. This is, some of you have older kids, like 4th, 5th, 6th grade. Yes, they might have to relearn some stuff, or things that they think they know, we're now figuring out what does it actually look like. But the goal of problem solving, critical thinking, that is so much more valuable than a little bit of frustration just getting them through, just adjusting to a new program. We got to keep that in mind. The younger students, they're just going to catch on and they're going to be A for away. Some of the older ones, there's going to be a little more tweaking, and of course us as older and the way we learned it, when we come to them and say, no, it should be this way, we're not going to be able to, in some cases, explain it to them. And that is where the teachers really will be stepping in to do that.